Hello guys, welcome to another video. Today we'll be covering organic chemistry and the petrochemicals and polymers. So let's start with organic chemistry. It is the study of structure, properties, composition, reactions and preparation of carbon containing compounds which are called as organic compounds. So whenever I say carbon containing compounds, it is an organic compound only. So carbon as an element is very unique because it forms multiple covalent bonds. It has four valencies, a plus 4 or a minus 4 valency, which makes it very useful to us. And we are made of it. Our DNA is made of parts of carbon. And due to its variety, an entirely new branch of chemistry is created, which is called as organic chemistry, which is completely based on the way carbon reacts with other elements. So here you can see the variation of carbon atoms. So here you can see that we have diamond, coal and even our body. There's a huge difference between all of them, but surprisingly all of them contain carbon. So hydrocarbons, the simplest form of carbon compounds consists of mainly hydrogen atoms. These are called hydrocarbons. These compounds are only made of hydrogen and carbon atoms. They are divided in two categories: saturated and unsaturated hydrocarbons. Saturated hydrocarbons have all of their covalent bonds satisfied with no more room for adding another atom or another element, and the examples include alkanes or cycloalkanes, and they have low reactivity, while unsaturated hydrocarbons have bonds which are satisfied. Like you have a satisfied bond with a double bond or a triple bond, but you can break that to get a much more stable single bond, and to do that you can add more elements or other atoms of or an entire molecule if required. And the examples are alkenes, alkynes, alkyls and aromatic compounds, and they are very reactive, and they are much more reactive than saturated hydrocarbons, only because they are not stable and they do not have that single bond. They have double bonds and which can easily be broken. So naming and formula. So all of these alkanes, alkenes, alkyls, alkynes, alcohols and carboxylic acids, they have their own functional groups or and have their own homologous series. So these functional groups of alkanes, the functional group entails that there is one specific characteristic of this kind of compound. For alkanes, it is that they have only single bonds and their formula is CnH2n plus 2. All alkanes have a suffix that end their ends go with ane, and the homologous series go from the first carbon atom. Like if there's in alkanes, the homologous series starts with methane, then ethane, propane, butane, pentane, hexane and heptane. So we have these numbers. These numbers entail the number of carbon atoms present in that compound. So for an alkane, for methane, we have only one carbon atom present. In the case of alkenes, you cannot have prefix starting with meth, because alkenes or alkyls or alkynes in itself, we have the formula of CnH2n, where if you plug in the number 1, which is for one carbon atom, into the point n, we get CH2 only, because we have C into 1, so like only one carbon atom, and hydrogen H2 into 1, so we get only CH2. We have still we still have minus 2 remaining of carbon atom, and we need 2 more from somewhere. Therefore it is incomplete, and you cannot have a methane or a methane prefix to an alkene. Directly starts with ethane. Same goes for alkynes as well. Next up on the list we have alcohols and carboxylic acids and esters, but we'll deal with that later. For now, we are going to look at alkanes and alkenes. You do not have alkyls and alkynes in your syllabus currently, because it requires much further study. We have first alkanes. They are saturated hydrocarbons, meaning they have one pair of covalent bond only. The boiling point increases as more carbon and hydrogen atoms are added, and the physical state therefore also changes from gases to liquids to solids. Naturally, if the boiling point is increasing, that also means that the physical state will keep on changing. So likely the methane would be a gas, while a decane or a dodecane would most likely be a liquid or a solid because the boiling point is high. This is because more carbon and hydrogen atoms are added, there are more bonds formed, that's therefore it's difficult to break them apart. Using this, the most likely the compound, say with 100 carbon and 202 hydrogen atoms, this is a ridiculous number, but it is most likely a solid at room temperature. They are very good fuels but release carbon dioxide as greenhouse gas. Uh, this is a very dangerous to our environment because it is the main perpetrator of global warming. So we have LPG or liquefied petroleum gas that we use in our day-to-day lives for cooking. That's what goes this is the fire, the blue colored flame that comes from your stove. So a blue colored flame is very important because that's what differentiates between the fuel completely burning and the fuel not completely burning. So what happens is that there's complete combustion. That's what gives a blue colored flame. That means it is safe, only carbon dioxide is released. But if there's incomplete combustion, that means that not all of the fuel is reacting. There must be some kind of constriction in the gas pipe. The yellow colored flame can be seen. It's a very faint yellow colored flame, and that is very dangerous because the fumes released from that are carbon monoxide, which is a toxin. It's a poisonous to our body and it can kill a human being. Next up, we have alkenes. They are unsaturated hydrocarbons with carbon-carbon double bond, which can easily be broken, and hence they are very reactive. You can use that to make an alkane through a process called hydrogenation. As the name entails, we have hydrogen being added into the alkene with the help of a catalyst of nickel and a temperature of 300 degrees Celsius. You can test whether an substance is alkene or alkane by adding bromine water. It is a test for saturation, to be honest, because if you add bromine water to any unsaturated compound, it will decolorize it because the bromine reacts with it. So it will not remain brown. The brown colored is because of the presence of bromine. But if bromine reacts with an alkene, it decolorizes it, making it colorless, like here. So an alkane will make the bromine water remain brown, but an alkene will change its color. So if you react ethene with the bromine water, it will form dibromoethane and it will change color. It starts with ethene, like I said before, and it is used in the making of alcohol with hydration. So this hydration process is also very important. As the name suggests, we have to add water or steam into it. You have to add steam with alkene at a temperature of 300 degrees Celsius and 60 atmospheres with phosphoric acid catalyst. And these alkenes can also be used as fuels. Next up, we have substitution reaction. This is an important part because this can be asked. This is frequently asked in IGCSE exams. So you can add an halogen to an alkane to get a compound called haloalkane. This is a photochemical reaction and it requires the presence of sun. More specifically, it requires the presence of UV rays. So for an example, if you react methane with chlorine, which is an halogen, you get chloromethane and hydrochloric acid. This is the reaction you need to know. We have CH4 plus Cl2, you get CH3Cl plus HCl. You can further add more and more chlorine to get dichloromethane, trichloromethane or tetrachloromethane. The trichloromethane is actually chloroform that you see, which is a drug which can make a person unconscious, and it's very dangerous. Here you can see trichloromethane, and this is chloroform. Next up, we have alkyls. These are incomplete and require one more hydrogen. They're found in compounds and not on its own since the bonds aren't satisfied. It is found in esters and they are formed through alcohols. It is used in halides and it is useful as a solvent. Next up, we have alkynes. They also do not start with meth prefix like alkenes. They are unsaturated and have three carbon, like a triple carbon bond. So they are commonly used in hydrogenation and hydration as well, like alkenes, to make different organic compounds. Here are some IUPAC names of alkynes. You have ethyne, propyne, butane. So ethine is actually used in acetylene torches. They burn very brightly and are used for welding purposes. Excuse me. Next, we have carboxylic acids. They are organic acids with the functional group of COOH. They can be found in bee stings like methanoic acid and in vinegar as ethanoic acid, also known as formic acid. They might ask you in the exam, like as formic acid. You do not be confused because formic acid also means methanoic acid. If you combine these with alcohol in the presence of a dehydrating agent, like concentrated sulfuric acid, this is a very common dehydrating agent, and if they ask for it in an exam, you have to write concentrated sulfuric acid. You can use that to form esters. It is formed using a special double bond of carbon and oxygen and an oxygen hydrogen with the same carbon atom. So we have a COOH over here. We have a carbon and oxygen, they have a double bond here, and then we have a single bond between carbon and oxygen and a single bond between oxygen and hydrogen. And then this R group, you see, it can mean anything. If we are looking at methanoic acid, this R could mean only one hydrogen. If we are looking at ethanoic acid, this R could mean one carbon and three hydrogen. So it really depends on what kind of compound you're looking at. This is its functional group, the COOH. Next up, we have alcohols. Organic compound with a functional group as OH. They can be created by various processes, like I told you before. First up, we have a hydration of ethene, and next we have fermentation, where yeast perform anaerobic respiration, giving out ethanol and carbon dioxide as byproducts. It is used as a fuel, also known as biofuel, and it is better than petroleum or gasoline because it is renewable and the net carbon content in the atmosphere remains zero. Because if you burn a plant and then replant it, the carbon dioxide that you release from the fuel, it can again be used up by the plant in photosynthesis. It can also be oxidized to form carboxylic acids. So you can oxidize it by the presence of a strong oxidizing agent like potassium manganate. It can be used to make esters and also can be dehydrated to get ethene back. So we have hydration of ethene, but then you could add concentrated sulfuric acid to an alcohol uh, to get, like, if you have hydration of ethene, you can get you can get ethanol. So but if you add sulfuric acid, concentrated sulfuric acid to ethanol, you can get ethene back. Ethanol is the only safe alcohol to drink in moderation, and in excess it causes damage to the body, for example liver cirrhosis. Here you can see this is an example of the fermentation process. We have glucose, which is fed into the nutrient inlet in a fermentation chamber. The aerator provides oxygen or it stops oxygen depending on what kind of respiration you want to take. Then we have stirring platters to stir the yeast around, and the yeast use their enzymes to turn this glucose into ethanol. They digest this glucose, they use it as nutrient, they use it as food, and they released ethanol and carbon dioxide as waste products. The same way we respire, we release carbon dioxide and water, right? But we do that as aerobic respiration. This is anaerobic respiration, where they convert glucose to ethanol. Esters. Esters are aromatic compounds made of alcohols and carboxylic acids in a strong dehydrating agent. It has an alkyl and an OH group. They smell very nice and are used in a variety of substances like perfumes or food additives or food colorings. A carboxylic group connects the esters. So what I mean by that is that, look here, we have an OH group of an alcohol, the alcohol forms an alkyl group. Suppose we had used ethanol here, it forms ethyl here, and it goes to this side. Like here you can see the red, you can cross connect here. So we have ethyl, it is the CH2 and CH3. Then we have propanoate, which is formed from the propanoic acid. So we have ethyl from ethanol and propanoate from propanoic acid. So what happens is that this COOH and the OH, they react together to give only COO, and the H2O remaining is dissipated as water. But then the presence of dehydrating agent like sulfuric acid removes it from the equation, giving us only an pure ester. So here you can see other esters being formed of ethyl propanoate, propyl methanoate, methyl butanoate, and propyl ethanoate. So next up we have isomerism. So you have isotopes of any element. Suppose we have hydrogen, then we have an isotope of hydrogen where you have two neutrons. You get deuterium or tritium depending on a number of neutrons. Here it is structural isomerism. We have a same chemical formula but a different structure. So it has the same chemical property but it has a different physical property. So the different compounds are known as isomers. Alkanes with carbon atoms have isomers. Alkenes with four or more carbon atoms and double bonded carbon atoms can be moved across the compound. So what I mean by that is, look here, we have like propanol. Okay, so we have a like we have OH group to the end, like we have one propanol. So what if you move it to the second carbon atom? You can count it from right to left or left to right, but it is easier to count it from left to right because you read it that way. So if you count it from left to right, you can see that on the second carbon atom we have put an OH, so it's 2 propanol. Again, if you look at say butene, okay, so if you have but1ene, we have a carbon atom, so we have a C which is double bonded to the second carbon atom, and then we have a structure of butene. But what if you shift that to the other side, you get but2ene, so we have a double bond in the center of the structure. That gives a different physical property than but1ene. So that's how you can number isomer. That's how you differentiate between an isomer. Like if you have but1ene and but2ene, that's how you differentiate between them. It depends on their structural formula. Next up, we have fractional distillation. Now we are getting into the petrochemicals and polymers part. So, petroleum or crude oil is first dug up. It is a fossil fuel from ancient organic matter. It was decomposed, and under intense heat and pressure, it undergoes a change to form uh, coal or natural gas. This is evaporated until, or it is boiled, which is the correct term here, until it splits up in different parts according to the boiling points. These boiling points, these depend on in the fractionating column. That's how it works. The gas which boils the first is the refinery gas, which goes on the top of the fractionating column. Then comes gasoline, naphtha, kerosene, diesel, fuel oil, lubricants, and bitumen. They are used for cooking, for refinery gas, gasoline for cars like general vehicles, naphtha for making chemicals, kerosene for heating, diesel for trucks, fuel oil for ships, and like lubricants, like as it suggests, you use it to lubricate things, and we have bitumen for roads respectively.